and a very warm evening. Welcome, good evening, that kind of thing. I've already messed this up. It's only, 30 seconds in? Oh well. Hi to Red Rider, I see you in chat. Hi to everyone else. I wonder how many of you are coming straight from our Summer of STEM that's currently running at the moment. It was a wonderful session of wonderful Wi-Fi today, taught by Rama. So if you enjoyed that today, then great. And if you haven't signed up yet, you can still sign up to the Summer of STEM at any point. All you have to do is go to this link and sign in. Hello to you too, Karen XX. Yeah. So, today I thought we would do a little bit of pinball programming. By that I mean making a game of pinball. And because it's me and I'm a creature of habit, of course, if we're going to be making the game, it's going to be in arcade.makecode.com. It's not the best game engine out there, but it is by far my favourite. Oh, I can't use the right buttons today. There's a link in the chat if anyone wants that. So, we're going to go ahead and make a new project. And you can give it whatever name you want. Now, pinball games go way back. They're one of the most popular sort of weird, not sport, but kind of sport. I don't know. How would you describe pinball? Anyway, it's a popular genre. So there's going to be countless names out there. So I'm just going to be boring and call mine Pinball Game. And click Create. Now, you lot should be pretty familiar with arcade.makecode, and as you know, it doesn't run so smoothly on my computer, so I'm just going to minimize the simulator on the left, and we're going to go ahead and get started. And the very first thing you're going to need in a pinball game is, of course, a ball. So I'm going to go to Sprites. I'm going to have this block set my sprite to sprite of kind player. And I don't want to call it my sprite, so I'm going to rename the variable just by clicking on that drop down arrow. I can rename it to ball, just to be boring. And in a pinball game, the ball's not really the player, it's more the bats, or more the paddles. So I'm not going to have it as a sprite of kind player. I'm going to click this drop down arrow and change it to sprite of kind projectile. Because that's the closest thing. We can always make a new one, but it's just easier to use projectile. And if we click in this grey box here, I'm able to design it. A little bit limited on colours, but not that. I'm going to click undo, start from the middle. That will do, and if I move it over a little, no, that's pan. If I select it and move it over, no, it could do with being one larger. That's the only problem with MakeCode. I'm not so fond of this sprite editor. It's a little bit finicky. Doesn't always behave. You know what? That'll do. I'm not going to be particularly fussed about how good it is. I just want to make a nice little pinball game. And there we are. We've got one ball. And it's already loaded in the simulator, says he, remembering that the simulator takes ages to open. There we are. It's just sitting in a blank, mindless void. We're going to start filling that up. So we've got a ball. We'll need something to whack the ball. We're going to need a paddle. And again, I'm going to go to sprites. I'm going to set my sprite to kind player. And it's not my sprite. This is going to be, let's rename the variable, left paddle. Now, I'm aware that drawing sprites in MakeCode takes a long time, partly owing to the finicky sprite editor. So I'm only going to do the left paddle today, which, you know, just to make sure you get to all the fun, good physics stuff rather than dealing with, you know, lots of pixel art and sprite work. When I've finished off, you're welcome to add a right paddle yourself. Or you could be one of the pinball games that only has a paddle of one side. They're rare, but they are out there. Let's draw this. I'm going to make this a bit bigger, actually, because the paddle needs to be wider than the width of the ball. And if we go back to our ball is less than 16 by 16 pixels. So I need to make the paddle wider than 16 by 16. So I'm going to go back to the paddle. And down here in the bottom left is where you change the canvas size. I'm going to make this quite large. I'm going to make this 48. So it's 48 pixels wide. And I'm going to make it 32 pixels tall. And the reason I'm making it tall is because we need to remember that a paddle flips up. And so at some point we're going to need a sprite where it's got the paddle flipping up. And this is to give us room later for when we design that. One second, talk amongst yourselves. There's some construction going on outside. I don't know if you can hear it, but I'm just going to fix that. Sorry about that. We've been teaching Summer STEM all week, and as typical when it comes to my turn to teach, construction starts happening outside. It's typical. Anyway, I'm going to draw the paddle. Again, I'm just going to make this rough, not too neat. I just want something quick and easy so I can show you all the fun stuff. And a little bit of colour just to make it stand out. Let's add some orange in there. Maybe some turquoise. Maybe some... Oh, you know what, that'll do. I should learn not to be so perfectionist about this. I'll go on then, just a little bit more. Nope. There we are, I'm done. It's not important. You know, we can always neaten it up later. This is just to get something down so we can work with it. Okay, if I look in the simulator now... Come on. We can see that they are currently stuck together. That's not all that useful for us. So I'm going to move the paddle out of the way a bit so we can work on the physics of moving the ball around. Because it's hard to design the physics if those two things are colliding as soon as they are created. So I'm going to go to sprites and I'm going to set my sprite position to something something. And rather than my sprite, which doesn't exist, I'm going to set the left paddle position. And let's just move it just to the sort of bottom left of the screen. Let's say x equals 1 and y equals 108. And whilst we're there, we can start creating the basic, physics for the ball. And we're going to add more physics to it later, but this is just the basic stuff. If we go to sprites again, we can actually set properties of sprites. If you scroll down past effects, to past projectiles, past overlaps, in fact, above all those, I was scrolling too far. I've lost it now. Where have you gone? My mistake is inside effects. At the bottom of the effects tab, we've got this set my sprite, stay in screen, on or off. This is the property stay in screen, and you can toggle it on or off. We're going to do that for the ball. We don't want it to stay in screen because, have you seen the size of the screen? It's tiny. We want our pinball game to take up much more than that. I'm going to click this drop down arrow, and instead of just having it as stay in screen, I'm going to have it as bounce on wall. And I'm going to make sure that bounce on wall is set to true. So I'm going to click this toggle switch here. And whilst we're there, I'm going to give it change another of its properties. I want it to show physics. And this is a debug option. And it allows you to see the physics of the ball and understand what's happening with it. So if you go to sprites again, and just as before, at the bottom of the effects tab, we've got set my sprite stay in screen. I'm going to change that to ball. And it's not going to stay in screen. It's going to show physics. And we're going to click on. Now, when we finish the game, we can turn that off. And in fact, when people are developing games, developers will often have lots of debug information, showing them how things are working. It's all visual on the screen for testing, and then they'll turn that off when it comes to actually releasing the game. And a good example of debug information is I don't know whether it still does this in the Bedrock edition, but certainly in the Java edition of Minecraft, you used to be able to press F3, and it gave you all the debug information that the developers use for testing the game. But anyway, let's put a little bit, let's get the ball moving. To coin a phrase, let's literally get the ball rolling. If we go to sprites, what we're going to do is we're going to affect the velocity of the ball. And we'll be using velocity a lot. And it's basically how much speed does it have in a given direction. So we're going to get set my sprite velocity. We're going to change that to ball. And we're just going to leave it as it is for the moment because this is just a test. Because if we look in the simulator, we now have the ball moving. Just about. You see the text underneath the ball? That's the debug information. But it's just there, sitting, happily bouncing around. And, well, it's a bit like the DVD screensaver. There we are. Okay, so you may have noticed there that there is something up with our ball, and that it's not very realistic, is it? It's not moving like a ball usually would under the presence of gravity. In fact, there is no gravity. This is anti-gravity pinball at the moment. We're going to fix that. We're going to give it gravity, basically. We're going to make it look much more realistic. So, we're done with on start for the moment. We're going to set a different stream going. What we're going to do is we're going to constantly measure the velocity of the ball, and we're going to say if this ball has an upwards velocity that is too small, as in it's not going fast enough upwards, then we need to start dragging it downwards. That's basically what gravity does. If gravity had a personality and a voice, and you asked it what its job was, it would say, if things are going up without any speed, I need to start pulling them down. And that's why rockets can escape the atmosphere, because they've got enough speed going up. So, how are we going to do that? Well, if we're measuring this constantly, we need to measure on every frame of the game. So if you go to Game, in the Game tab, you can find this block here called On Game Update. And what this means is every frame of the game, the console will take a look at what's going on and it'll update with any new information. So this block basically is triggered every frame. And depending on what game you're playing or what console you're on, that could be 30 frames per second, 60 frames per second. VR headsets are now pushing 120 frames per second, which is ridiculous. But yeah, that just happens a lot and very often. And what we're going to do is we're going to test the velocity of the ball. So we're going to go to logic and we're going to grab an if. And we're going to say if the velocity of the ball is less than a number. So if we go to sprites, the fourth block down, this is the property value block. It sounds like a bit like Monopoly, doesn't it? We're talking about property values. But this is the value of a property of a sprite. So if I grab that, and I'm going to pop it there for a moment, it's unhappy because we haven't put it anything. I need to compare this with something. I need to say whether it's less than. So we're going to need a less than block, which you can find in logic. And under comparison, it's a comparator. So I've got this. I'm going to grab my property value block and I'm going to jam it in there. And we're going to jam it in the if statement. And now we're going to change all of these things. So the first thing to change is, well, as this error is telling me, we haven't used my sprite before. This is all about the ball. So I'm going to change that to ball. And that error will disappear, thank you. And we don't want the X position of the ball. We want the speed of it up, down. So that's Y. Y is up and down. So velocity, Y. And we want to test whether its upward speed is less than a certain threshold. Now you can choose what this number is. And changing that number will change a couple of things. So let's just pick for now 200. Okay. If the ball doesn't have enough upward speed, we should start bringing it down. And to bring it down, we need to start, put in some weight to it. We need to sort of give it some downward velocity. So we're going to go to Sprites and scroll down to the 5th block down where it says change a property of my sprite by something. And we're not going to change my sprite because that doesn't exist. We're going to change ball, and we don't want to change its position. We want to change its y velocity. And what we're doing is we're going to add onto its downward y velocity by a small amount, so that the more it is slowing down going up, the more it is speeding up going down. Sounds confusing, but when we have a look, it will all make sense. I'm going to change this to a number like 10. And I think if we have a look in the simulator now, we should see that it bounces quite nicely. Now you can change those two values to be however much you want. I think if I change this one over here back to, let's change that to 100. We can see that it moves a lot slower and it also bounces much less. If I change that to something like 300 and change this one to, I don't know, 60, we can see that it moves a lot faster and it's got it's got a heavier bounce. So this is your game. You change those numbers to be what you want. I'm going to leave it on 200 and on 10 because that's what I made the prototype with, and that seemed to work quite well. And it all, how you design your game will depend on what these two numbers are. Anyway, actually, to go back a second, you'll notice that even if it slows down completely, it is still constantly hitting the walls at the same speed. If you look at the 50 on the left, let me pause it. If you look at this here, we can see that the x velocity is always either 50 or minus 50, and it never changes, and that's quite unrealistic, and it doesn't make for a very fun pinball game. So what we're going to do now is we're going to say if you hit a wall, we need to change the x velocity. We need to take a little bit of x velocity away. So if I go back to my code, this is going to still happen in the on-game update, and we're going to do it in a new if statement. So if we go to logic and if, well, basically what I want to do is I want to say if I hit the wall on the right, give me a little bit of right velocity. And that sounds weird, but what I'm doing is if I'm given right velocity, it's taken away from left velocity. And if I'm taken away from left velocity, it means I'm not moving left as much. So, as an example, if we go to scene and we scroll down, there should be a diamond-shaped condition that, yes, it's in collisions. You can say, is my sprite hitting wall in a certain direction. It's this one here in scene. And rather than saying, is my sprite hitting the wall, of course we change that to ball. Let's do left first. So if it hits the left wall... Ooh. Someone slammed a door. Apologies if that made too loud a noise. Anyway. If the ball hits the wall on the left, then it should not go. It should slow down its journey to the right. So to do that, we need to go to sprites and change my sprite. Sorry, change my sprite's property by a number, and it's going to be the ball, and we're going to be changing this time its x velocity. Velocity x. And if we want to take away from right velocity, well, right velocity is a positive number, so left velocity is going to be a negative number. So let's make that something like, I don't know, minus 30. Hits the wall on the left, and it takes 30 away from the ball's right velocity. And that happens each time it hits a wall on the left. We're going to do the exact same thing for hitting a wall on the right. So I'm just going to click this entire if statement. And I'm going to do right click, duplicate. And I'm not going to say is ball hitting wall left. I'm going to say is ball hitting wall right. And I'm not going to change the x velocity by minus 30. I'm just going to change it by 30, positive 30. And let's watch that in action. So it hits the wall, and it should be slowing down. Why is it not slowing down? What have I missed? Oh, crumbs! That's what's the that's the problem. Oh, silly me. It's not hitting the. It's not slowing down because even though these are walls, they're not the right kind of walls. That's it. When we look over in this bit of code here, the wall to the left it's talking about is the wall of the tile map. And we haven't made the tile map yet. So I'm going to make the tile map next. It's alright, we've written the right code, it's just it's not going to be useful to us until we have a tile map. So, back to on start. If I go to scene, I can scroll down and find set tile map to and a blank space. And this is where we can design our tile map. So if I click there, we're into the tile map editor. Now this tile map is 16 tiles by 16 tiles. And that's fine if we wanted that, but we want this to take up the width of the screen and be a lot taller as well. And I know for a fact that the width of the screen is 160 pixels. So if each tile is 16 by 16 pixels, and we want to fill up the whole width of the screen, how many tiles do we need? We need only 10 tiles. So by clicking down here in the bottom left, you can change the size of the tile map. We want it only to be 10 tiles wide. And if I just draw out some quick tiles, let's go for the, not that one, let's go for the black one. Actually, no, let's go for the, let's make it colourful this time. Let's go for this sort of creamy one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 across. And as for height, you can change this to be any number you want, but you want it nice and good and tall, so I'm going to change that to 32. And there we are. Now, this is where we can design our playfield. We can design our the way our thing looks. So if let me just, actually, let's fill the whole thing in first with this sort of blank background, and then I can add a little bit of extra details as I go. Should I go for that one? Is there any better? Not aquatic. Don't fancy dungeon. Anything good in Misk? No, good. You can always click My Tiles here and paint your own tiles, just by clicking that plus icon. But I'm not feeling it today. Let's just carry on using these. A little bit left. Yeah, carry on with that. Now, a couple of things that we're going to need. We're going to need a place that the ball dies when it enters. So a bit of fire, a bit of lava, something like that. Luckily there's this little lava one. I quite like using this one. You can use whichever one you want to. Let's have a little bit of lava in there. You also need somewhere for the paddles to rest. Now, I've worked out the sizings on this, and I find it works best if you have a gap in the middle of around about 4 tiles, but it is entirely up to you, and you can of course change the tiles to be smaller, larger if you want to. A little bit of a mistake. Actually, let's make these stand out. I'm gonna... Yeah, let's make them stand out. Just a little bit of unnecessary extra stuff. Doesn't have to be included, but it's just a nice little bit of set decoration. And it's something that I get terribly distracted with. I could spend all day doing this. I promise I'll move on in just a second. One last little bit. 2 last little bits. 3 last little bits. Right, there we are. Okay, it's a little ugly, but I don't care. I'm just making this for a bit of fun. We're also going to need some bumpers. And that's something for the ball to bounce off of. If I go to miscellaneous, I quite like using these buttons here. You could paint your own or make new ones, but these ones work quite well. I'm just going to scatter a couple of bumpers, and these are for the ball to bounce off. Let's put one in there. And just a small, another one. Yeah. Stick it there to be annoying. Just to really annoy any player. Now you can add a lot more to this. You could draw your own backgrounds. You can, make it quite interesting. You can add some very interesting parallax effects by adding in a background rather than a tile map. But before we do anything, the most important thing to do is to tell the engine which bits the ball should bounce on. And to do that, we're going to use the wall tool. That's a really awkward thing to say. It's like a tongue twister. Wall tool. If I go to this sort of 3D pile of bricks, this is the wall. And when I click, it draws a red box on top of the tile that I click on. And the idea is to cover the every tile in this red square, every tile that the ball bounces off vertically. There we are. Now, we're not going to do the sides. We're not going to do this bit down here or this bit on the left, because when you do a tile map, it automatically draws this red exterior around the whole thing. You can't see it, but it's there. We're also going to need the red tiles on the bumpers. And that should be everything. And now we can click done. So if we open up the simulator, which will take ages, we can see, I don't know whether you saw that, but our ball is now falling through the world. But we can't see anything because the camera is just staying in the same place. So we need to get the camera to follow the ball. So if you go to sprites, scroll down, and no, I'm lying, ignore me. Go to scene and scroll down. We can find the option to camera, follow, sprite. And if we change that to the ball, we can now see that the ball is falling through the world and it's bouncing along nicely. And we know that our wall stopping velocity checks work. It's not carried on going left past the wall that the tile map has employed. And it's also hit against this wall, which means that it's slowed down. It's not bouncing back and forth between the two forever. Okay, with that all in place, the only major thing to do is to work on the paddles. Now remember, I'm just doing the left paddle at the moment. First of all, we need to actually move the left paddle down to around about this location here. And that requires a little bit of trial and error. So I'm going to have this be... Let's change that to X is, I'm going to guess 90 something. And Y... No, not 90. If I'm going... sorry, just a little bit of mental maths. If it's 48 pixels wide, and it needs to go 2 squares from the left, that's 32 plus 16, so that's 48. Let's try 48. 48x. And if the whole thing's 32 times 16, which is 32 times 16, 512 pixels tall, I need to go up around about 3/4 of that. So 512 times by 0.75. Let's guess at 384. And let's see if that works out all right. And how embarrassing my math skills are. Let's see. Okay, so the paddle should go up a little bit. It's also 16 pixels too far to the right, so I need to do 48 minus 6. Yeah, I need to do 32. I thought it was 2 squares over, not 1 square over. So I reckon x equals 32, y equals, that's 1, 2, 3. 3 times 16. 48. Goodness, my maths is very embarrassing. 340. Yeah, 340. Okay, so it needs to go up another 16 and maybe across 8. So make that 40. And minus 16, so that's going to be 320. No. Let's just put 28. You know what? It's not perfect, but I'll go on then. I'll make it perfect. That's going up another 5, so 322. There we are. I've got a paddle. That's all I care about. There's the problem with being too perfectionist. Anyway. Now we've got that, we can actually add some controls to the paddle. And basically what we're going to say is, if the player has pressed a control, signal the paddle to be up. And if we want to store that signal, we're going to have to store it in a variable. So, in controller, you can find on button pressed. And I'm going to stick with A button. We're going to set a variable to true. So if you go to variables, I can make a variable, and I'm going to call this left paddle is up. Maybe not up, maybe fired. Left paddle is fired. And in the same variables tab, I can find set left paddle is fired. And I'm not going to set that to 0, I'm going to set it to true. And you can find true on its own in logic. And it's at the bottom, right down here, in the Boolean section. Set left paddle is fired to true. Now, the first thing I should do when my paddle is fired, after telling the game that it is fired, is I should flip the paddle up, which means I'm going to need a new sprite or a new image. If I go to sprites, I don't want to use set sprite because that makes a new object entirely. I just want to change the image of the sprite I already have for the left paddle. If we scroll down to the bottom, we can find the set my sprite image to. This replaces its, if you're familiar with Scratch, it replaces the costume rather than the object. And this is for the left paddle. And rather than redrawing the whole thing again, what I can do is I can grab our drawing of the paddle we've made before and just... Right, why is it not letting me duplicate it? Come on, you did it this morning. No? No? Fine, we'll duplicate the whole thing. See if I care. And then we'll just grab it out. No? You're not letting me grab it out anymore? What is this nonsense? Ugh, fine, we'll have it your way. We'll redraw the whole thing. So remember, that was 48 by 32 pixels. So we need this one to also be 48 by 32 pixels. Now it's not going to be neat because when I did this before, I was going off the duplicated version of the previous sprite, but we'll make it as close as we can. You know, I blame Microsoft, as I often do for these things. It might not be Microsoft's fault, but I blame them nonetheless. Now this is going to be the paddle flipped up. So for that, I'm going to redraw it slightly differently. Now it's a little skinnier this time, but who cares? And then I added a little bit of extra patterns, didn't I? And then I had that one. Yeah, and then I had red. And then I had a black circle filled with a kind of purpley colour. Now you can spend as much or as little time on that as you like. So we managed to get it to flip up. What should we do next? Well, we should wait a little while and then it should return to its original position. So we can go to loops and pause so many milliseconds, which is an alright way to do it. However, there is a sort of cheaty way that has an added extra benefit. If we go to music and we have this option to play melody at tempo, because this uses up so much of the processor, this also acts like a pause block. In fact, you could call these two things the same thing, except this one plays a little bit of music. And depending on how long your piece of music is, well, how fast it plays, is also how how long the pause is. So it's not the most reliable option, but it is an option. And if we can get away with writing less code, then that's always better. So I'm just going to do a little ditty, something like maybe, yeah, just something a little fast, just to do a sort of the paddles being hit. And I'm going to make this really fast. I'm going to make this 600 beats per minute, and I'm changing this down in the tempo section. So that's going to be our paddle flipping up, and it's going to play this at 600 beats per minute, and then it needs to flip back down again. And I'm just hoping this is going to work, because this wasn't for some reason. Why? Why is it only saying help? Why? It's never done that before. So I'm going to do is duplicate this, but I'm going to get rid of this one. Oh. It's not gone rid of. Okay, I'm going to grab this one and move it down here. I think that works. I think what's happened is, since I've used this last, I believe the Microsoft have updated the software, because it's behaving a lot differently. Like, it never used to have this red dot. So yeah, I think what they've done is they've removed duplicate for sprites, and instead you just click it and drag it to duplicate it, which is odd. I'm not sure if I agree with that, but that seems to be what they've done. Anyway, so we flip the left paddle back down, and afterwards we need to also change it back to not being fired. So I'm going to set left paddle as fired. I'm going to duplicate that, and change it this time to false. Let's give this a little test. I'm going to go to simulator, and you should be able to press A, which is space on the space bar, and you can see that the paddle flips up and then it comes back down afterwards. And also, whilst doing it, it plays a lovely little ditty. Okay. Now, how do we get the paddle to actually interact with the ball? Well, that's a nice simple-ish chunk of code. At least I think so. We're going to basically say, when the ball hits the paddle, if that paddle is the left paddle, if left paddle is fired, then flick it up in the air quite fast. But if it isn't fired, flick it only a little bit, just to get it off the paddle, just to bounce a little bit. And the best way of detecting that event is with an event block. And we can find that in sprites. And if we scroll down to overlaps, we can find on sprite of kind player overlaps other sprite of kind player. We're going to use this one. But we're going to change it from player to... No, we're going to leave it as player. My mistake. We're going to change this second one. So on sprite of kind player overlaps other sprite of kind projectile. We're going to change this to projectile. Because the sprite here refers to any player that gets hit by the ball, and this other sprite refers to the ball itself. If we go to sprites, what we're going to do is we're going to check that this sprite is the left paddle. So if we go to logic and we grab an if, we need a comparison, so we go to logic again and we go for equals. We're going to say, is this sprite equal to left paddle? So I'm literally going to grab it right from here. I'm just going to grab the sprite and I'm going to stick it in the first part. And I need to compare it with left paddle, so I need to find left paddle, which is a variable and it's stored in variables. Left paddle. If the sprite is the left paddle, then I need to do something. And what do I need to do? I need to ask if left paddle has been fired. So I need another if. And I need to compare the variable left paddle fire. Goodness. Someone's in a hurry. Who's holding down their car horn? That's horrid. Anyway. I don't know. My neighbour's been terrible today. Anyway. If the left paddle fired equals true, well, let's sort that out. We need a comparison for that. So equals. If we go then to variables, we can find left paddle is fired. And we need to say, is this true? We can find true in logic at the bottom. If left paddle is fired equals true, then what do we need to do? We need to fire the ball massively up in the air. And we're going to do it in a way that's not very realistic, but is cheap and easy to do, and is, it's a little bit hacky. But what we're going to do is we're going to fire it up in the air by a random y velocity. So if we go to sprites and we go down to change property again, we're going to change the property of the ball. And we're not going to change its position, we're going to change its y velocity. And we're not going to put a solid number in there, we're going to put a random number in there. And we can find random numbers in maths, the maths tab. And if you scroll down, you can find the pick random 0 to 10. Now, oh crumbs, I've made a mistake again. We're not going to fire it up. We're not going to fire it up by a random amount. We're going to fire it left to right by a random amount. So it shouldn't be y velocity, it should be x velocity. So change this drop down to be x velocity. And we're going to say we're either going to go minus 100 left up to 100 to the right. So it's going to pick between those two values. So it could go straight up, or it could go straight up to the left, or straight up to the right. We haven't got the up yet though. And for that we are going to change the y this time. So sprites, set my sprite velocity. That's going to be the ball. And no, not set, sorry, change. Sprites, change. I'm going to change the ball. We're going to change its y velocity by something massive to go upwards. It needs to be a minus number. So minus 500. Okay. What happens though if the paddle currently is not being fired? Well, if we click plus here, we get an else block. So this is what happens when the paddle fired is false. And we're going to do the exact same thing. So I'm going to duplicate these two blocks. But I'm going to change the values to be much, much smaller. Because this is it just bouncing off the paddle, not flying off the paddle. It's just doing a tiny little bounce. So we're only going to move left to right by either minus 50 up to minus 10. And so going to be always minus because this is the left paddle, so it needs to go right. And we're going to change the y velocity by only minus 100. Right. Now there's only one more thing to do. And that's to change the velocity of the ball when it first appears in the world. Because if it always has the velocity 50-50, there's always going to move towards the bottom right. So we need to change that by a couple of random numbers. So if we go again to math, or maths, if you... No, I'm not going to be insulting to Americans. I'm going to bite my tongue. Math or maths, whatever you want to call it, that's fine. If I pick random for both, and I change these numbers to be from a minus number to a positive number. Now it mustn't be too large, just enough. So if we go, let's say, minus 100 to 100 for the x, and minus 50 to minus 50 to positive 50 for the y. That should be enough. Let's see if that works. Okay, that time it got stuck. I'm going to talk a little bit about how that can be fixed. No, it went through our paddle that time. Why did that happen? Oh, come on, stop getting stuck. It likes getting stuck in that corner, doesn't it? There we are. It hit the paddle once. That's all I need to show. Obviously, the game will become much more playable with a second paddle. That requires a little bit of sprite design to draw the paddle mirrored. Or if you're clever, you can actually flip the image of the left paddle to create the right paddle. But that's a couple of extra steps. Anyway, we've now got the bare bones of a lovely little pinball game. You can add the code so that when it gets in the lava, it either loses your life or spawns you back to the start. But there we are. We add the paddle hitting the ball. And there's another thing. If you wanted to stop the ball getting stuck anywhere, which it does do, you can add what's called a tilt button. And lots of pinball games have this. It's where you press tilt, it shakes the camera, and it adds a little bit of momentum to the ball just to get it unstuck from where it is. But in any case, I hope you enjoyed that. It's always fun to take a game, get the basic physics engine sorted, and then just experiment to your heart's content. That's what I'd like to see. Just a reminder that we do have our Summer of STEM on the go. You can sign up at any time. Not only do we have 15 days of fantastic activities, but we also have some evening classes which run from 4 to 6, which are more, not more advanced, but they're more technical. They're much closer to computer science than these activities up here. And that's the reason why I won't be running this session for next week, which is Thursday the 13th, because that will collide with the Mashing It Up with Machine Learning, which is a great little activity. I might be tuning in for that one just for fun, just to see how the Cardiff Hub are doing it, because it's Cardiff teaching this. You've got all sorts of opportunities here. So you won't see me around for the next 2 weeks, but after Thursday the 20th of August, the week following, which will be the 27th, I will be resuming these sessions. If you want to make any specific requests for these sessions, I am putting a link in chat. You can go to this link, which will open up a survey, and you can use this survey to request whatever you like. Now, this survey is a little bit old. I used this last time. I stopped TechnoClub for a week. I'll be changing all this description, but you could suggest a topic that I might cover. We've had requests so far for more Python. I'm always happy to do more Python. Put in any request you like here, as long as I can show it I can demonstrate with an online website, then I'll be able to show it off on TechnoClub. And I'm also accepting challenges. These aren't required to be a website. This is just a fun little challenge you want to send me, and I will do a stream where I complete that challenge. Nothing too outrageous. I've already been challenged to make a 20 level game that's inspired by The Legend of Zelda. I'm going to give that a go just as soon as I work out the logistics. And I'm not sure my internet connection will stay stable enough for that. We'll see. Anyway, I hope you've had a lovely evening and enjoy the Summer of STEM. Bye.